Yes, hello and welcome to today's second workshop. The topic now is analog spacesuits. We have created a bit of an overview. Yeah, we would like to talk about suit systems, about fidelity, how realistic is an analog spacesuit in comparison to the real astronaut suit, the real spacesuit. What are the practicalities, and what are human factors which play a role in the design and the use of spacesuits. So, does anybody have any initial idea of what we need to consider when we talk about analog spacesuits?
No chafing.
Absolutely.
And maybe like room for, I mean, the astronauts wear diapers, right? So I think, and we can also like simulate the same thing because why not?
Correct. Why not?
Yep. And the comfort, yeah, it definitely has to be comfortable, no chafing. And I think the thickness, whatever thickness of the spacesuit material is used in like real life, I think we should be simulating that, because I think it's really, really hard to be, it's very easy to work with like very, very thin suits, and you might feel like, oh, I can write or do or use a tool or something. But when it comes to like really thick gloves and really thick suits, it's kind of like, it's a different ball game at that point, right?
Yeah.
So
No chafing.
definitely.
So we have more people arriving. Welcome, everyone. We have just started our discussions on spacesuits, and we have jumped into human factors directly. Yeah, the spacesuits have to be comfortable, no chafing. And you also correctly managed that astronauts and also analog astronauts should wear diapers like the astronauts going to space do. Yes. Any other aspects that we need to consider when we're talking about analog spacesuits? And maybe we stay with the human factors, comfort, and things like that to start with. Yeah, we have provisions. Yeah, astronauts, analog astronauts during EVAs, they have to drink. If they go on an 8-hour EVA, they probably need to eat something, to have a, I don't know, a granola bar installed inside the helmets. And as we said, human waste handling. Yeah.
Can they have liquid diets, like, you know, something in the form of liquid, like the nutrients in the form of liquid, so that it's easier for them to sip on?
Yeah, they can sip a smoothie, for example. Yeah. This is a bit small. Yeah, liquid food. Yeah. Something. Yeah, banana milkshake, for example. Whatever they prefer. Yeah. What else do we have to consider when it comes to that?
Hello, maybe the possibility of recording the activity.
Yes.
Video or
Absolutely.
Other items.
Mm-hmm.
Video recording, yeah. Something
Yeah.
integrated.
Mm-hmm. So we had suit systems, yeah, monitoring, recording. Of certain
Recording.
parameters.
Video, or maybe also audio recording,
Yeah.
taking notes. Or...
Yeah. Note taking is possible because we have, of course, speech recognition systems, so the astronauts can just talk to their software, and the software will make the notes.
Yeah. Awesome.
Yeah.
The suits can also record vitals of the astronauts.
Mm-hmm.
Okay.
So medical systems, yeah, recording of vitals. This gets so small. This.
Maybe especially those sensors we talked about during the safety workshop.
During which virtual? Sorry.
The sensors for the safety that we talked about in
Mm-hmm. Yeah.
the previous workshop.
Yeah. That measure the heart rate and things like that. Yeah. So oxygen in the helmet, CO2 in the helmet. Yeah.
Okay.
Especially from what I know, these there's a plenty of these sensors, but usually they are like standalone. So trying a way to implement everything in the spacesuit could be like even more comfortable, and as we said earlier,
Like wearables. Yeah.
yeah, I mean, instead of wearing for example one sensor for the heart rate and biometrical parameters, one for other, like it would be great to implement everything like when you wear the suit, you have everything measuring all the data.
Yeah.
Okay, I think I will say the same, but I will try to organize it. I think what we are missing in analog spacesuit is the informatics system. The informatics system, which includes the health monitoring wearable technology, which includes all the sensors for.
Hello.
And then also
You
the ventilation.
were breaking off. Can you just repeat the last sentence?
Okay, which one? Okay. I was talking about the biomonitor system, which is included in the informatics system. So this bio informatics system sends all the vital signs like for a screen or something like this. So you could be like with astronaut vitals, you could have watched him, know his heart rates, his temperature, everything. So also the ventilation system is good in this really in this current analog spacesuits. So I think there is no thing to add on it.
Why is it always on 14? Yeah, ventilation system. Mhm.
Also in the informatics system, we have the lighting system, which
Sorry?
is very important when it's dark.
Yeah, like lighting.
Yeah, lighting system.
Mhm. For night EVAs, yeah,
Yeah,
or for or in a cave where it's just dark.
yes. Also depends on the environment we are going to. If we are going to like simulating Mars, so it's very cold, so we have to have to include this thermal garment. Thermal garment that we that is consist of resistant materials that when you connect it with power, it the heat rise.
Mhm.
And when you are in environment which is hot or something like this, you use the cooling garment.
Mhm.
Yeah, I think this all I can add right now.
Yeah, I think that's what the astronauts on the ISS do when they go for spacewalks, because they really have a rhythm of 90 minutes of day and night. So as soon as they're out in the sun, they need to use the cooling because it gets really hot. And once the sun is gone, it gets really cold. So they need to switch on the heating instead. So they have this permanent rhythm every.
Yeah, but what we can use during the simulation or during analog space missions,
Yeah.
I think it's biomonitoring system. It's the most important thing for simulation, I mean.
Yeah. So that would be these systems, yeah, physiological monitoring, yeah. That the vital signs, or do you want to measure anything else? Like this would include like the heart rate, the rate of breathing, things like that.
Yeah, and also the humidity inside the spacesuit.
Mm-hmm. Yeah. Mm-hmm. Absolutely. Would you, we are talking a lot about physiological measurements, yeah. Like, would you also, should we also include psychological measurements, like indicators for elevated stress levels or fatigue?
Yeah, I think it depends on the measurements of the spacesuits. It play a very important role in the psychological effect, and also the ways of comfort, the mobility itself, it affect the psychological part.
Absolutely. Yeah.
So a question.
Yeah.
Measurement is okay, you know, suit can do all kinds of measurement, but how do we stop a person like, hey, you have elevated stress levels, please stop whatever you're doing? Like, and yes, it comes down to you have to follow orders and everything, but you know, what if the stress levels are too much and now somebody has become psychotic and everything? Like, what can the spacesuit do itself that would like actually prevent the astronaut from doing whatever they're doing, you know, kind of a stop button?
So, Bhumika, you mean that normally not the meadow or the mission psychologist, they wouldn't say anything, but the suit would automatically
Yes,
give a message,
suppose,
alarm.
yeah,
Yeah.
Yeah, like suppose if the person who's in charge of like all the medical things is
Mhm.
not on the EVA side, right? And the person single-handedly,
Yeah.
like for example, on the ISS, hopefully there's always two people who are working outside the system, right? ISS. But what if there's just one person and now they're like alone and they have higher stress levels? What can the spacesuit do to prevent like any injury to the person or to the system now because of the higher stress levels or psychological issues and everything, you know? Or
Yeah.
do we always need one other person to kind of stop the hazard or like the situation?
So far, most of the, I only know of one exception. Most of the EVAs are done with at least 2 analog astronauts. And there is, of course, in mission control, there is somebody normally sitting, a medical officer, and usually both medical officers and psychologists, who can just say stop at any time.
Sounds good.
I also think that
Yeah.
when you have a screen in your arm or something like this, telling you all the vital signs, all your vital signs, and if any issues happened with the spacesuit, the system with AI telling you that how you could fix this issue and
Yeah.
calm down and something like this, I think this could be an answer to.
Yeah, absolutely. I would even put this on a entire level of suit systems. Yeah. When there can be a problem with the EVA that, for example, they go out with a robot and the robot malfunctions, and the suit can give some ideas of how to fix it, but also there can be something wrong with the suit itself. Yeah.
But if I may, I feel like this is maybe too much of an invasive limitation for astronauts. Well, they are trying to check their parameters, so maybe a level of trust in their capacity should be respected, because stress is it's not the same for everyone. You know what I mean?
Yeah,
So,
yeah, of course.
So I don't think that people will be very happy having this kind of limitation. To me, is maybe a little warning, but something that clearly stops or tells to stop.
I can tell you they don't like when the meadow says stop.
Yeah, I can imagine why. So,
or when the mission psychologist says stop, they don't like that either. So
I know they are working in a very hostile environment, but I think that trust in their training and capacity is important too. So
yeah, but there is also this factor of competitiveness. Yeah.
yes.
Yeah.
That could be a kind of a problem.
I can't possibly tell anyone that I'm feeling stressed right now.
Yeah. I understand that too.
Yeah. I will not get to go on the next EVA if I show any signs of weakness. I mean, stress is a natural reaction. It's not a weakness. It's actually
it's kind of an issue, but
yeah.
Again, they're working, so too much of control it could be problematic, I think.
Yeah. We can put this here as a point. Not too much. Yeah. That they don't feel monitored every single step they take. Yeah. But they usually are. Yeah. So this, of course, ties in with the human factors. Yeah. That it impacts the feel-good factor. Yeah, if they feel too controlled.
Absolutely.
Yeah. So if we look at the human factors, we have here flexibilities, we have hand motion, yeah, because we need to do things with our hands during an EVA. Can we execute large motions like with our arms, spreading our arms or taking a large step while in the spacesuit? And what are the limits of motion? What do you think about these factors?
I think in analog spacesuits, there is a skeleton that work on restricting the movement. I think this will be a good simulation, but also we have to work on more on the joints of the spacesuit, of the analog spacesuits.
Yeah. Manos says for flexibility, I think that the spacesuit's composition should be limited to 9 layers of different fabrics maximum. Yeah. So limitation. Of fabric layers. Is there any reason, Manos, why you choose 9? Seven to 9? Do you want to elaborate on that? Why not 4? Not 3 or 12?
I think
Yeah.
okay.
Cumbersome, yeah.
It's a magic number.
Yeah.
I think in analog spacesuit, you are not simulating all the scenarios, so you don't have like to have a fire resistant layer, or you don't have to have like a bulletproof layer or a waterproof layer unless you are going to Nemo or something like this. So I think there is a lot of layers that we can work without in analog spacesuits. So I think it just could be the outer chilled and
Yeah.
the cooling garment or the heating garment and the biomonitor layer. I think this could be enough in analog spacesuits.
Yeah. So we shouldn't overdo it. Yeah. What about visibility? Any ideas there? Is any of you a diver? Scuba diver?
I am.
Okay. Would you like to elaborate a bit about visibility?
What do you need in particular for visibility?
Yeah, when you're wearing a mask and everything.
Yeah. Well, it depends. It really depends on what you want to do, but it's not the same environment. So I'd say well, it depends a lot of the distance between the glasses and the eye.
Yeah.
And also what is around the glass. For example, I know that as I do also underwater shooting for photographers and video makers, they tell you to choose a mask with a dark surrounding of the glass, and not a transparent one.
Yeah.
For the lights, in order to better see what you are filming. But I think that distance between glass and eye, it's very important.
Yeah.
I can be more specific.
Yeah. Absolutely. Yeah. If you have it directly in front of your nose, or if it's like 30 centimeters away, it can make a
and the white also, the white of the glass is important.
Yeah. Exactly. Like what's your
side field, something like that. Yeah.
Yeah. Degrees of vision, yeah.
Peripheral, yeah.
Yeah.
Also, sun visors is important.
Yeah. Sun shading, yeah. And what we have learned from Chris Hadfield, who once went blind during an EVA because of his anti-fog system, or rather, I don't know if you've got the story. They put some anti-fog inside the helmet for the EVA, but there was some chemical that caused irritation in his eyes. So of course you don't cry in space because your tears won't flow down because there's no gravity. So the tears actually stay in your eyes and they don't fall out, and then you don't see anything anymore. So that is also, then they change to a different anti-fog substance that they're using. But this is also, of course, an issue when you go diving, that you have to make sure that.
Is there something also to, because I'm thinking also to the accident to Luca Parmitano with water in his helmet.
Yeah. He was almost drowning. Yeah.
He said that since they resolved this problem, but it could be possible to imagine some system of aspiration of water in the helmet, if any. But I mean, on Mars would be the same issue, because they were in microgravity, so water doesn't react the same way.
Yeah.
There is a gravity on Mars, so it's less of a problem.
Yeah.
But nonetheless.
I mean, getting to Mars on the way there, it can potentially be a problem. Yeah,
so maybe a system to aspire water.
Because they can potentially, they have to do some repairs to the spaceship while traveling to Mars and have to go on EVA while they're en route to Mars. Yeah. System to avoid drowning in helmet.
Yeah, water aspiration or.
Yeah. Absolutely. Can happen. It did happen. We can put it there even in people are still coming. Yeah. As it happened before. Yeah. So the helmet is obviously a very important piece of the spacesuit system.
Scratch resistance on the visor.
Sorry, Bhumika, come again?
I said scratch resistance on the visor.
Yeah.
Yeah. And I've only seen Martian, and that
Yeah.
might be a like a very worst case scenario where they're like stuck in the storm. But you know, I mean, I'm scared of if my visor just had a crack or something.
Yeah. That is very true. And crack, scratch and crack resistance, yeah.
Yeah.
And we know the lunar and Martian dust is very, very aggressive in that kind. It's like it can cause some damage, like abrasion. It's not very
Yep.
it's not like sand on the beach. It's really spiky, so to say.
Yeah. And when the astronauts, they're outside the ISS, I mean, we have space debris and whatnot, so it can always, they're like, and I don't know how to save astronauts from that, because usually the debris is traveling at a very, very high speed. So I don't know how far can we go with the ability of the visor's material, you know?
Yeah, it's actually the entire suit system has to be protective against micro meteorites.
Yep. And if we talk about all these protections, and then we kind of are comparing that on the planet Earth, we don't need these many layers. But do we need the endurance of the people who are actually testing these suits to be actually testing with all the layers? Because one day or the other, we need all these layers, you know?
Yeah.
We can't just be simulating something that's not gonna be a reality, you know, once we go to space.
Yeah.
So how do we account for that? That okay, on Earth we only need 4 or 5 layers, but in space we need I don't know how many layers.
Yeah, so here we come to the field of fidelity. Yeah.
Yep.
How realistic does it have to be? And I would argue that it comes with the level of fidelity that we want to achieve.
Yep.
Yeah, because if what is the goal of the mission?
Yep.
Yeah. Is it to test if an astronaut in a spacesuit can perform certain movements, like using a tool to actually take soil samples, then the glove and the entire body movement is important. But maybe for other experiments it's not so important. Yeah, so we don't need such a high fidelity in the spacesuit, and we can still perform the experiments. Yeah. So spacesuit needs to match the fidelity requirements. Yeah, we don't have to be we don't have to add fidelity that we don't really need for us to achieve certain goals in the mission. Yeah. Is it just you want to simulate what it feels like if you wear a helmet, so you just take a motorbike helmet, or do you really want to have the full experience, with also like 50 kilos of weight for the spacesuit, and yeah, what do you really want to simulate in the Mars simulation, if that makes sense? Yeah. So we have the weight. Does it have to be realistic, or do we say, okay, you know, we just want to check a process, if that works. We want to check if we can start and land a drone. Yeah, we might not need a fully weighted spacesuit for that. Yeah, we can still use test the functionality of the drone.
We may maybe talking about weight, consider the gravity on Mars.
Yeah.
So maybe thinking of light equipment.
Yeah.
I mean, try to simulate the gravity astronauts will find on Mars. And so
this is like what the Austrian Space Forum, they have these spacesuit simulators, and they would, the spacesuits for Mars, they would, what we know now with the technology, they would weigh 150 kilos.
Yeah.
So adjusted for Mars 1/3 gravity, they're on Earth, they're carrying 50 kilos spacesuit.
yeah, exactly.
Exactly, yeah. And then we have the question of pressurization, because in space we need a pressurized spacesuit. Should we have pressurized spacesuits for analog missions? Any thoughts?
Maybe yes.
Yeah, can be important, yeah. Right now, mostly this pressurization is simulated with an exoskeleton, limiting the movement, because that's what pressurization does. It limits the movements that astronauts can do. And the exoskeleton does that as well.
Yeah, I think we don't need it because when we are out there in space, there is a difference in pressure between outside and inside, and this causes the spacesuit to be like a balloon, and this is the reason of movement distraction.
Yeah.
So on Earth here, it will be like the same pressure inside and outside the garment. So I don't know. I think skeleton is the best like choice.
Yeah. So it can be simulated by an exoskeleton. Yeah.
Yes, but then there is also the issue of being conditioned atmosphere and isolated from the external environment, and this isn't. I think this is important to test.
Yeah. So that would go here, yeah. The simulation of
Yes,
isolation
isolation,
from
isolated internal atmosphere.
yes.
So they deal with an isolated atmosphere, a real pressurized suit.
Yeah.
And that's important psychologically also. I think it's not the same tool if you work with a real pressurized suit.
Yeah.
Also, I was thinking Should we talk also about procedures like emergency procedures for this functioning?
Absolutely, yeah.
Because I was again thinking of the Parmitano case, and I think when I read about his case, he waited, and also ground control waited, so they haven't immediately stopped the EVA, and
yeah, if I remember correctly, they stopped the EVA immediately, but then he had to first of all get back into the airlock.
Are you sure they immediately stopped the EVA? Because I remember Parmitano saying I have water in my helmet, but ground control said something.
I'm not entirely sure about that, but I'm pretty sure that, I mean, even if you did stop the EVA immediately, it takes time to get back from where you are to the touch of the ISS, because you can't just fly there. You have to very carefully, hand over hand, and still taking the tether with you. And then he went into the airlock. But in the airlock, you have to repressurize first. So they have the proper pressure. So you can't just take off the helmet once you're inside the airlock. And pressurizing the airlock, that takes time. So they had to wait for that. Plus then they opened the inner hatch so he could get back into the livable quarters of the ISS. And then it still takes time to take off the helmet. It's just not that you press one button and the helmet comes off. No, it's not like that. So there was, I remember there was a long time of waiting, and there was still, when he was back inside the ISS, the danger was not gone. Yeah.
True, and with all this in mind, could we imagine some emergency procedure when when a malfunctioning is declared, they immediately stop the EVA. So emergency procedures of this kind.
Yeah.
Considering you are not an immediately emergency exit, so to speak.
Yeah. Yeah. For example, your ventilation system stops working.
Yeah, but they have all this stuff now. I remember the Russian cosmonaut having some issues with his battery, and they immediately tell him to come back inside.
Yeah.
So, but I think it's important to maybe structure this too.
Yeah, I mean, there has to be general rules for EVAs. And there has to be special rules for what to do with the spacesuit. Yeah. So we have the emergency doffing, because normally also doffing can take up to 90 minutes to actually take the spacesuit off. It's not just like taking off your sweater. Yeah, it takes an awfully long time. And sorry. And there are, for example, in the Austrian Space Forum, we have some procedure emergency doffing, which is also trained. So we skip some of the steps, so it goes faster. But it still takes time. So there still is danger that something can happen. What would you consider requirements for safety of spacesuits? Any idea? Inbuilt systems, procedures, alarm bells? Any ideas?
What's the meaning of doofing?
Oh, sorry. It's just taking off. Putting the suit on, it's called donning, and taking the suit off, it's called doffing.
Okay.
Thanks for the question. Yeah. And sometimes when there is an emergency, you have to take the spacesuit off very fast. For example, somebody cut themselves and it's bleeding. Yeah, you can't leave them in the, yeah, they cut their arm. You have to take the suit off to actually tend to the injury, or in this case of Luca Parmitano, to stop him from drowning in his spacesuit.
I think the best option is going like the next generation spacesuits, going into the spacesuit from the backpack
Mm-hmm.
and getting out from the backpack. I think this is like the fastest way.
Yeah. Mm-hmm. Yeah.
So from the backpack.
Yeah. That you kind of put it on like a jacket rather than having all these different elements like trousers and suits and helmet and upper torso. Yeah. Manos agrees with the backpack answer. Yeah.
But also the helmet should be removable. We could remove it if he had like some problems, like water leak or something like this. If the helmet is removable too, it will be faster.
Yeah.
Like, but in different situation.
Yeah, absolutely.
But not outside the ISS, right?
No.
Yeah. Because that was
Yeah.
so it would have emergency, like it locks itself because it knows that it's in an outer space condition. And
yeah. Yeah, and wearing an exoskeleton like a backpack, which is going to be worn like a shirt. Yes. We have to distinguish a bit between a real spacesuit and a simulation spacesuit. So in the simulation spacesuit, we would like the astronauts, the analog astronauts, to wear an exoskeleton to actually limit their movements. Whereas in real space, we want them to maybe to wear an exoskeleton that helps their movements. Yeah. So, and we have in analog missions, we see the entire range from in terms of analog spacesuits, from an overall that you can buy in a DIY store, worn with a motorbike helmet, to really like the Austrian Space Forum have these spacesuit simulators where they test all kinds of things. I mean, they even have experiments from ESA regarding the material used for the spacesuits, that the regolith doesn't cause any abrasion. So what do you think about that? Should that be standardized, or it is actually an advantage that we have the wide range of these spacesuits? Mind you that the very high fidelity spacesuits are very expensive. So what would be a good, would it be good to have standards, maybe one standard or different standards?
I think it should be centralized, because ultimately, why are we doing all these analog missions, right?
Yeah.
And I know it's gonna be a lot of cost initially, but once we centralized everything, we have to realize it's for the high fidelity environment ultimately. And that's what we have to test for.
Yeah.
But
It's
that's
just
just
that would kill a lot of analog missions.
Yes, initially.
95% of them.
Yes. Yes. But we can define like minimum operating, some requirements
Yeah.
that we just can't have, like you said, like the DIY store overalls, jumpsuits. But we can define like a minimum,
Yeah.
at least this has to be it. So
maybe we can have different classes of spacesuits. Yeah, a class
Yes.
A, class B, class C.
Yes, according to the fidelity of the mission, like you suggested, like if you're just collecting soil sample, you're not, what kind of movement do you do with your spacesuit and everything? And then if you're visiting some caves or something for some mission, what kind of spacesuit you'd be wearing and what fidelity is required out of those spacesuits.
Across all analog missions, yeah.
But some like basic safety requirements, like it has to have a comms. I mean, that's kind of important because every analog mission has like mission control side, which is constantly communicating with the people who are on the field. Thermal, like stabilized, I don't know, internal pressure, I am kind of on the fence on that one.
Yeah.
If the pressurization is required, but yes, like comms, temperature regulation,
if necessary.
yes.
Because in Habitat Marte it will be warm enough, we don't need any temperature regulation.
Yes.
Yeah, we don't have to classify them right now, but it could be a good idea to have also to, when we move forward with a general standard for analog missions, then we should maybe also have standard classifications of analog spacesuits. Yeah. Like you have, like, if you buy a sleeping bag, yeah, you have classifications. Yeah, this one is class, I don't know if it's class A or 1 or whatever. Or buy a bulletproof vest. Yeah, you have class so and so, that is yeah, resisting bullets up to mini Uzi or something like that. Yeah. A sleeping bag, you have classifications. Yeah, this one is up to +5 degrees. This is up to -10. Yeah, everything has these classifications. Spacesuits don't have it yet. So
And in the policy, it should be like, hey, if you're doing certain kind of mission, you should be wearing this. But like, if you're wearing a class A spacesuit, you're not allowed to do some high fidelity analog mission because that defeats the purpose, right? At that point, even though it's easily available or it's cheaper and you're doing some high fidelity mission with a class A spacesuit, I mean, I think it defeats the purpose at that point, right? So it should be a requirement like in the policy or something.
Yeah.
Which needs to be followed.
Yeah, so we have this in alignment.
I think there is already several types of spacesuits. Depends on the mission. Like the one for ISS, the EVA or mobility unit spacesuit. And we have also the IVA, the one that SpaceX is famous for.
Yeah, the cool one.
It doesn't have like a pressure garment or something like this.
Yeah.
I think it's more simple because it has like a specific task. And also like if we get back to Apollo and we see the spacesuit right then, they were just jumping on the moon because the mobility was so bad. And in the next generation, they can walk because they worked on the mobility, because they are going to collect samples, not to just walk on the moon.
Yeah.
So yeah, it's there is several types of spacesuit depending on the mission, like the EVA, the IVA, planetary spacesuit, re-entry and launch spacesuit.
Yeah.
So we already have several types of spacesuit depending on the mission.
But we don't have it in analog spacesuits yet. So we should get more closer to reality, to real spacesuit classifications. And
yeah, I mean the one in Antarctic, not like the one in Poland.
Yeah. Yeah. Absolutely.
Only if we had Iron Man suits, right?
Yeah, I think it's gonna be the next generation spacesuit, like Iron Man spacesuit. They are working on adding a lot of features to it, like that. Like you can now see a lot of things about your mission on your visor, on your helmet. So they are working to make it like science fiction.
Yeah, it's not fiction anymore. I mean, if you look at the analog spacesuits from the Austrian Space Forum, they have this heads-up display. So they see in their visor, in the display, they see what they have to do. They get the steps of the experiment, take a rock, pick it up, put it there, and they get every single step we can display in the suit, in the helmet. Yeah.
Oh, so it's already exists. I thought they are still working on it.
No, it exists. Manu says, I was thinking of armor-like parts covered in lead for radiation protection. These are going to be part of the outer layer. Are you thinking of going to real space or analog spacesuits? Because lead is almost as heavy as you can get. We have during the Amadi 20 mission 2 years ago, was it 2 years ago? Yeah, 1.5. Tested some STEMRAD vests, but I think it's more like Kevlar because lead is very heavy and it doesn't bend, and because they were also, the analog astronauts also had to sleep in them for some nights to see if it's comfortable. Yeah, and they have now gone into space on some dummies, not on real astronauts, the same vest that we were testing. But it's it's a different. I'm not a specialist in radiation protection. I know lead actually keeps a lot away. I'm not sure if it's the best material to keep radiation away. It's certainly cheap. I mean, lead is very cheap as a material. Yeah, Giuseppe, you know that because you have a weight belt and you need to get rid of weight, just let it go. Doesn't cost a lot.
Absolutely.
Of course, other materials are more expensive, and that can also be a factor. Yeah, and we have actually something here. Cost efficiency is paramount. Yes, absolutely. And we should actually put it in here. Yeah. Cost. Yeah. Yeah, I don't know how this works. Mixing a lead with other lighter materials. Could be. We can put it in here. Maybe was the 100 material of that and something lightweight, whatever that may be.
Like fiberglass.
Yeah. If that also keeps radiation away, or in combination with lead, as I said, I'm not an expert in that.
Yes, it is.
Okay. Like fiberglass. No. Maybe that's an option, but it is, of course, it is a criterion to look at the costs as well. No. So in-suit intelligence, anything we want to see there? What the suit should do by itself?
What do you mean by intelligence in this case?
Maybe virtual reality or augmented reality, something like that. Help?
Kind of to make the simulation more realistic, or
For example, or more safer.
I mean, are you talking about something to simulate the mission, or something that should be integrated to the real
In the analog mission.
intelligence? Heads up display, record keeping that.
For example, I'm thinking of, you have a very limited field of vision.
Yeah.
And you might not be able to see a big stone that is right in front of your foot. Yeah.
Okay.
You saw it when you walked there,
Yeah.
but then you started doing some experiment, and you forget that the stone is there.
Okay.
And you don't see it anymore, and you want to take a step forward, and boom, you fall. I don't know if that's
Collision prevention. Then we need collision prevention from the cars.
Yeah. Yeah, I mean, is that an option? And
Yeah, just adding some sensors.
Yeah.
Especially if the rocks or something is like really pointy, that might not be a bad idea to have that in-suit capability actually. Because it's not just rocks, like, you know, once we land on Mars or something, I mean, structures around us, you know, the habitat structures and everything that might actually cause us to collide with them. And if we're not, you know, very, very cautious and everything. And I think a intelligent suit might actually help prevent the injury, damage, and everything.
Yeah.
But how do we integrate that, you know, efficiently? That's the question.
Yeah, that's for the engineers to solve. So Bhumika, it's your field.
Talking about that, there are already scuba diving masks which incorporate the the diving computer data.
Mhm.
I mean, you have some, yeah, you have some of these masks which have a little display
Yeah,
placed just in front of your eye inside the mask, and you
Yeah.
can read all the parameters,
yeah. How much or how much air is left in
the
your
depth, everything you
and
want.
what's your
So,
depth and what's the outside temperature?
so basically, you are not to watch your arm
Yeah,
to know these parameters. They are just in front of your eye. So
Yeah.
maybe some kind of similar solution.
yeah,
Yeah, but we have to be careful, like, you know, the visor's surface area is like limited. So what vital information needs to be displayed at what time, you know, when we're doing things, that's also very,
Yeah.
very important.
it
Because we
might
need
not have to be displayed all the time, but kind of alarm when something is off limits, then you get an alarm flashing in the visor or something like that.
It's not exactly, actually, it's not exactly the last model I saw. It's not exactly in front of your eyes. It's kind of a little bit under
like a
your eye.
holographic.
And you can give a look to your little display or not. So it's not really in front of you all the time.
Yeah. So I mean, I don't need to know all the time when I'm diving how much air I have left, but every now and again, and I need to know when is my halftime, when is my 50%, when is my 25%. Yeah, I need to.
Yes,
Yeah,
but
something
you
like
need to know your depth, you know your dive time.
and the decompression time.
If you have decompression.
Yeah.
But
Well,
I don't know
that's not really
I don't
well,
know what are the parameters
when
for
we do underwater, when we do underwater analog missions, we haven't yet touched that subject yet.
Yeah.
We need very different suit systems for underwater missions, for simulations, underwater analog missions. Yeah.
I
So
think in underwater missions we can use the diving suit as a waterproof layer and heat-proof layer too.
yeah.
And pressure system would be must.
Yes.
Or we call them UEVA, underwater EVA.
Problem with underwater analog is that pressure gap is inverted.
Yeah.
Yeah, so you can't.
Yeah.
This is kind of an issue.
Yeah. Yeah, the pressure is, and you have the pressure constantly changing with the depth.
Yeah, and you cannot have a situation where you have less pressure outside than inside, and this affect the use of the suit.
Yeah.
The suit behave differently, actually.
Mm-hmm. Absolutely. That's true. Yeah. So I can't make it any bigger. So yeah, we will probably see more underwater analog research, simply because psychological experiments are much more realistic underwater than in a habitat, because you have more the feeling of or it's not a feeling, the danger of analog underwater mission is much greater. Now you have the same situation like in space. You can't just open, if you have a habitat on land, like Habitat Malta, you can always, in case of emergency, you open the door and walk out. Lunar is the same thing. You open the door, you walk out in case of emergency. If you're underwater, you can't do that. Yeah, and imagine there is somebody with a broken leg in an underwater habitat. Try to get them into a diving suit and bring them up to the surface. It's
kind of an issue.
It's just the same problem as you face on the ISS, and then depending on how deep you go, you might actually be faster to coming back on to Earth from the ISS than you do decompression from depth if you're saturated. Yeah.
Then maybe the underwater analog are maybe more interesting for tasks than for suit testing or analog suit testing.
Yeah, but it's we still need the, yeah, it's not for testing the spacesuit underwater.
I mean, you know,
yeah,
what I want to say is not testing the real spacesuit, but to test an analog.
Yeah.
To simulate.
Yeah. So we need to have analog spacesuits for underwater missions, which is currently normal diving suit. Yeah. And they do a lot of training for the astronauts going to the ISS. For the spacewalks, they do this underwater.
Yeah.
But it's not an analog mission, it's astronaut training, which is, yeah, being in the water is the closest we can get to microgravity on Earth, to long-term microgravity. I'm not talking about parabolic flights.
Yes.
But underwater, and you have kind of a lot of limitations that you have in space, and everything is difficult, and you can't just move around, you can't walk in the water like you can't walk in space. Funny that it's still called spacewalk. So
there is just a major difference. You cannot make strokes in order to move. In water you can,
yeah,
but in space no.
Yep.
It's a big issue.
Yep.
Okay.
So we need to have this in mind, that it can also be underwater spacesuits, analog spacesuits we're talking. Yeah. So if we go a bit back to the human factors, somebody in the chat. Yeah, in water you use the water molecules to propel yourself. Yeah, it's not the same as in space, but it's go into the ocean, dive 10 meters deep to the sea floor and try to walk on it. It's just you're just tumbling around usually, unless you have a lot of lead weight on you. Yeah. Yeah. So, but it's underwater missions. They will have a lot of traction for psychological experiments, because you don't have the thinking that, oh, if something goes wrong, I open the door and I walk out. You can't do that in an underwater mission. And this is why they will be very important in the future for analog mission. Yeah, Manos, you can come up with a patent for leaded for leaded protection, but this is for real spacesuits. We don't want to walk around with lead in analog missions, because here we have the full gravity, and it'll be just too heavy. And then again, we don't have to protect ourselves against radiation on Earth. So in analog missions, the use of radiation protection is quite limited, like the experiment we did in the Amadee 20, where it was about comfort. These radiation protection vests, how did the astronauts feel in them when they wore them, like all day long, and when they slept in them? That was about comfort, not about the actual protection function. Yeah. So we have one of the factors that are related to humans. We have sizing and fit. The analog spacesuits need to fit the astronauts, and that's not an issue, not a big issue. If you have an overall from the DIY store, yeah, they come in all different sizes, and if the legs are too short, then the legs are too short, and if they're too long, then you just hem them up. But with a real spacesuit, for example, the first planned or envisioned all-female spacesuits in spacewalk, it was like 3 years ago or 4 years ago, I've lost track. They had to postpone it because they didn't have the right size spacesuit for the lady up there. So also for analog missions, if we talk about high fidelity spacesuits, they have to fit for the astronauts, yeah. And astronauts can come in all types of sizes. Like I'm 1.83 meters, so I'm pretty tall. So I would not fit in any kind of analog spacesuit if it's high fidelity. Yeah. And then we had a discussion about para-astronauts, about astronauts with special abilities. For example, some astronaut has only one leg or has no legs. What kind of spacesuits would they wear? No. Do they get personalized spacesuits? Because the spacesuits they use in the ISS, they're also being used by different people. It's not that every astronaut has their own spacesuit. Yeah, so that is also something that needs to be considered, because ESA wants to send para-astronauts into space. They have already selected one, and who is actually missing one leg? What kind of spacesuit should he wear? Yeah. And how can we simulate this in an analog mission?
I think now they are working more on personalized spacesuits. And also there is a club called Girls in Space. They are working to design a spacesuit in the shape of a woman body. So they don't have to get into these bigger spacesuits.
Yeah. Yeah, so they have to be trend towards personalized spacesuits, yeah.
Also, there's another kind of spacesuits that is has like three like sizes that could fit anyone. Like it's not like many sizes or something like this. No, just 3 sizes, and it could fit with anyone.
Yeah. But what if that anyone only has one leg?
Yeah, I was talking about sizing, but here we will go to the personalized spacesuit.
Yeah. Hmm. Prosthetic legs, yeah, but they would have to be. I don't know how this would work, yeah. And that would not help with some other special abilities, but yeah. And is a prosthetic leg? I don't know how the spacesuit would work with that. I mean, this is something we have to test in analog missions, yeah. Test suits for yeah. So there is still a lot to do here on Earth, and our analog missions can certainly help with that. Yeah.
Yeah, on this, I
yeah.
had a thought on the people with special abilities and more on like the mental abilities I was thinking and how it relates to how we can make the suits, more intelligent.
A very good point.
I was thinking about like, suppose somebody has, epilepsy attack or something in mission or something. What can the spacesuit do to like how they start to foam and everything and shake? So what can the spacesuit do for them?
Mm-hmm.
Something like that, because ultimately we're all going to be there in space as humankinds, and how do we face these challenges, and how do we work towards the capabilities of spacesuit to include everybody with different abilities, right?
Suit intelligence for
And it's like people who only understand sign language, like how do we include that?
How do we communicate with them? Yeah?
Yes.
I mean, they
Yep.
can usually read. So
Yes.
if you put text there, but if you if they're deaf and you want to attract their attention, yeah.
Mhm. Yep.
So hey, there is something that you need to read, yeah, if they don't see it immediately.
Yes.
So, and you can't shout at them because
Yeah.
that wouldn't work, but like normally they would probably see, hey, there is a text or there is an alarm, but maybe the alarm is not functioning. You need always a backup way of communicating.
Yep.
So maybe even to blow some air into their face, yeah.
Yep.
As an alarm signal rather than
or vibration, maybe.
Yeah.
or vibration. Yeah.
Yeah. Approaching different senses other than what we would normally do, in space.
Yeah, this is
And
mainly here in suit systems and overall, yeah. Including this is that we're not only visual or hearing, because, for example, if you have the situation that you have water in your spacesuit, yeah, you might not be able to see and not hear. Yeah, you don't have to be specially able, but it can be a situation that causes vision and hearing to disappear because of the same incident. Yeah.
And I know we are talking about spacesuits, but the other thing I was thinking, like, if we're gonna have a diverse, crew for these kind of missions, I think training everybody to be aware of everybody else is also very important, how we communicate with like people with special abilities, how they communicate with us, kind
Yeah.
of, it's like very, very important at that point.
Yeah. So it's like include yeah, it's, I mean, communication in the spacesuit is difficult as it is. Yeah. So that is yet another challenge.
Yep.
Do
And,
we, yeah.
and just not communication, like, psychologically, how do we train ourselves, right? Mentally preparing ourselves,
Yeah.
like, so that's kind of very important, because at the end, it's just one crew, it's a team, right?
Yeah.
You all work together.
Yes. Yeah, including working with I have someone in there, yeah. So yeah, we see that on Earth that you meet people meet someone with special ability and they have absolutely no idea how to approach them. You can see that very often just out in the street.
Yeah.
And then they just walk away, they totally ignore them instead of just talking to them and asking.
Yep.
Yeah. So, yeah. Here we have already said cost reduction in relation to the radiation protection, but there is of course a general need for cost reduction for the entire spacesuit, for the electronic system, for the cooling system, for everything. And could costs come down, for example, if we say we have these three or these standards for spacesuit, class A, class B, class C, class D, that there should be some centralized buying of these spacesuits for all analog missions, then of course you buy more and you pay less. Yeah, you get discount if you buy more. What do you think?
I think cost is very high because it's like a monopoly industry for America and Russia.
Or the analog spacesuits. We're just talking about analog spacesuits here.
Okay.
Yeah. If you have high fidelity suits, like for example, the Austrian Space Forum has, they're very, very expensive, very expensive. If you just take the overall from the DIY store, it's like 19 euros or dollars. But the higher fidelity we get with the analog suits, the higher the cost will be. What can we do here on Earth in analog missions to bring costs down?
Investments from researchers out of their good hearts, because they wanna invest in this research, you know. And I mean, first thing would be to that, you know, to have investors.
Yeah, which doesn't really bring the cost down. It's still the same cost. It's just somebody else is paying for it. But it's of course to save costs in the mission, yes. Because the mission doesn't pay for it. But also like sponsors, yeah, I would add sponsors here. So the difference is an angel investor doesn't ask for anything in return. A sponsor, they want something in return, yeah. I give you so and so much money, and in exchange, I want my company logo displayed. Yeah.
For analog spacesuits, I think you could gathering a team from engineers as a crew, and their mission is to build a spacesuit.
Yeah, create a mission to get the cost down. That's a very good approach, yeah. To design a low-cost space, to design.
Like NASA competitions or something, or some other, you know, if you put.
Yeah. Something like that. And Manos is writing, the space industry is about to go boom very soon, so maybe costs are going to be mitigated. We are definitely going to see more and more and more interested investor in the future. Yeah, absolutely.
So, Karen, are you working with Astroland?
Yeah.
Okay, I'm working on building a spacesuit prototype right now with a team.
Yeah.
Like we could make a deal right here. You could offer me like a mission in Astroland, and I could build you a spacesuit, analog spacesuit with the same mechanical design like Artemis, the next generation, and have a like biomonitoring system with the cost that not exceed $1,000.
Would that be a real spacesuit or an analog spacesuit? Would it have an exoskeleton to restrict movements? Would it be a third
analog spacesuit? Yes, it's analog spacesuit, which have informatics system.
Yeah.
This informatics system has lighting system, camera system, and also biomonitor system.
Yeah.
And it consists of hard upper torso and hard lower torso, like the same mechanical design of Artemis, the next generation. What do you think?
Yeah, I mean, it can. Have you spoken to some of the missions, some of the habitats, some of the organizer? Because I'm not organizing missions.
Okay.
So
it's like a win-win situation.
Yeah, I mean, if you can do that, I'm sure somebody will be interested in it. But yeah, talk to Lunares, talk to the Austrian Space Forum, talk to High Seas, talk to Habitat Marte, and all the other
yeah, sure.
places. You might, I mean, if you can really do it for $1,000. a high fidelity suit, that would be fantastic. So I put in here as a point, ask Hossam. Yeah. So people can
Okay.
come to you. Mm-hmm. Yeah, I mean, that would be fantastic. To create a high fidelity suit for $1,000. Fantastic. That would solve a lot of problems for a lot of analog habitats. That is fantastic. Okay. Safety. We have spoken about emergency doffing. Anything else that we need to consider here? Control from habitat versus from the mission control center, telemetry system or systems. Anything to add?
Nothing in mind.
Yeah, about the intelligence of spacesuit, I think if we worked on a spacesuit like in units and give every unit its own sensor, then if we faced any problem, we could detect where the problem is. And at the same time, if we are going like on ISS or something like this, and we have like the two parts, part is very hot and part is very cold, then the sensors work and you can detect where is the cold come from and where is the hot come from. And then these units that we are dividing the whole spacesuit into units, only the units are facing like the cooling part, it start to heat up, and the other not, the cooling system start to work.
Okay. So
Like problem detection.
like, sorry, what? A problem detection, yeah.
Yeah.
Yeah. Where is the cold coming from? Yeah, where does the heating system fail? Yeah, is it left leg or right arm?
Yes.
Yeah. So sensors in multiple sections. Yeah, that can help. So one question from my side, if we have all these suit systems and we're sending this telemetry, we're measuring everybody's heartbeat and brain waves and whatever, how do we make sure that the data is kept secure? I don't want, for example, my heart rate published on the internet. Do we need?
No, you make a desktop program that is yours, and this is data is sent to it from Wi-Fi but it's not published on the internet.
Yeah, I know how it works. In theory, but a Wi-Fi is not always safe, and people are not always safe. You have hundreds and hundreds of people working a mission. How do you know that nobody just makes a copy of the data?
Don't we sign
We can-
NDAs and we can sue them and the data will be encrypted? And I mean, there are clauses, right?
Yeah. I'm just, I just want to address it.
I think it's important. Data is money. I think so.
Do we need a blockchain for our health data, or how do we do that? Yeah. So.
And I think ethics also come into play, you know. I mean, people can sign all the NDAs and they can still disclose information. So ethics is a big part
yeah,
of this
of
whole
data
scenario.
security. Yeah.
Yes.
Yeah. And yeah, that's people don't always do what they say they do. And when I sometimes give an example, I'm saying I'm not telling you in which mission this was, then it's because I've signed an NDA. So I'm not allowed to disclose such information. Yeah. So yeah, I think a lot of missions, they don't have a lot of focus on data security. I don't know what your experience is with that.
Can't say for myself, but anybody else in the audience?
Yeah, can you please
Yeah.
just fill in this health questionnaire on Google Forms? No.
Yes, we did this. And also the medical officer have all the information because he made it. He make it like, so I think between us as a crew,
Yeah.
like the only thing was very secure was the psychological tests,
Mm.
I think. Yeah.
Yeah.
But the health data like pressure, blood pressure, or weight, or these things, I don't know what the other crew members will do with this, so I think it's okay.
Mm. Yeah, I mean, of course, these missions require a lot of trust, and I'm not saying that anybody is betraying the trust. I'm just saying that we have to be aware that there is some risk.
Yeah, sure.
And that we have to keep it in mind. And if we work with ever more advanced suit systems, there will be ever more data and ever more sensitive data. And so data security is really a topic that we should be aware of, in my opinion. I don't know if you agree, but I don't want my data floating around too much. Momika agrees.
I agree.
We
I
have
mean, A, what are they going to do with the data? Right? But B, what can they do with the
sell
data?
it to your health insurance company.
Yeah. Yeah, because, you know, you have all the questionnaires on the health insurance, like, are you a tobacco smoker? Are you this and that? What's your weight category? What's your height and everything, you know? I mean, what do they want to do and what they can do? We don't know that, you know?
Oh, the problem is we do know what they can do with it.
Yep.
If your monthly insurance fee all of a sudden triples.
Yep.
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 It's yeah.
I think it's a choice, and choice should be given to everybody to have their data encrypted and secured. And,
Mm.
you know, so that's a big question. Like, how do we do that? And
Yeah.
yeah.
I have in a different context, I've been part of a psychological experiment where the agreement was that the questionnaires will be anonymous and that each participant had a code, and the code was known by one person who was not the experimenter. And like a couple of weeks into this experiment, the experimenter all of a sudden said, you know what, I can't really make out really good results from the data I get. So I really need to know which person is behind the ID. Can you imagine? This really happened.
Yeah.
So I freaked out. Absolutely no way, never, ever. Not in this universe and not in any other universe. But these are things that happen in real life, and I don't think he meant anything bad with it. But if everybody has agreed that it will be anonymous, then it's anonymous, period.
Yeah, I think at that point it was like, oh, we want to look our data better, or
Yeah.
whatever conclusion we want to draw, we want to look them like make them look better. So we want.
Yeah, we can't even tell if it's a male or female.
Yeah.
Or how old they are, or yeah. So we want more data. Yeah, no, this is not how this works.
Yep.
Yeah. So, yeah, do we have any more areas here in practicality? We said training, yeah, include training of communications for especially able persons in spacesuit, mental preparation. But what about so standard procedures, emergency training, support team training? Because if you have a high fidelity spacesuit, you can't put it on yourself. You normally need at least two people to help you put it on, if not more. Yeah, and I'm not talking real spacesuits, I'm talking spacesuits for analog missions. Yeah. The support team who actually helps the analog astronaut getting into the spacesuit, which is still, by the way, can take up to 3 hours, even for an analog spacesuit if it's high fidelity. Yeah, they need a lot of training. They need to know where this cable goes, where, yeah, what is the difference between the left arm and the right arm. Yeah. Which glove goes first and which goes third, if you can't tell by the sides. But yeah, do you see that important or not so important?
And are these trainings like, you know, you renew your training course and everything? Is there such a clause? Or, you know, because we are ever so like emerging every day, new technologies coming into play.
Yeah.
Like, how do we keep up with everything, renew our training protocols, have analog astronauts actually keep up with the trainings every so many months or every so many years?
Yeah, that's a good point. Refresher, new technology. Yeah, absolutely. Yeah, new procedures.
Is there a policy making body for analog astronaut trainings?
No.
Right? currently?
No,
Oh,
job is still open, grab it.
yay. And I think it should include, like, you know, how we were talking about the para astronaut that ESA wants to send, and they have already chosen one. So unless there is inclusion, did anybody think that we want to design a spacesuit for an astronaut that has only one leg? And how do we do that, you know? So unless there is inclusion in these trainings and these procedures making bodies, I think
Yeah.
it would be hard to like cover every aspect,
Mm.
you know, that we want to do. So I think inclusion is very, very important if
Yeah.
we're talking about the policy body.
Yeah. Diversity and inclusion, yeah. And the policies then, of course, must be trained. Procedures, policies, etc.
Yep. And then there is a feedback, right? Feedback loop from the actual people who are training for these things,
Yeah.
who need to be included, because they're the best people to tell you, like, oh, you know what, this point number, this didn't really work out in the field because of so and so. So how do we change it? How do we amend it? You know, yes, lessons learned.
Yeah. Exactly. That's very, very important. And sometimes the lessons are there, but we don't learn them.
Yep, because we have to implement, you know, in our next round of amendments.
Absolutely. So Eleanor just asked if we still need a lot of time. I said, no, we're almost ready. So we are probably, yeah, we should start the presentation in like 15 minutes. Yes. So this is what Julio was talking about earlier, that he printed some QR codes for the procedures to display in the habitat that we can just scan, and if the procedures change or the policies change, then we can still make sure that we always get the latest version. Because rather than having a printed document or a document on the somewhere in the cloud with different versions, yeah, there is always a risk that somebody picks the wrong versions. Yeah, so if you just have a QR code and the ones who create the new procedures and protocols, they have to make sure that they link the QR code to the latest version, and then everybody gets automatically directed to the latest version. And it's a quite, yes. We can do the presentation in 10 or 15 minutes. Yeah. What else? Anything we have overlooked? Or we want to go deeper into? Fidelity, anything?
It's okay.
Any more comments? Yeah, joint resistance, mechanical counter pressure. What do the engineers say? It's of course, the higher the fidelity, the more psychological pressure is on the astronaut and the more physical load is on them. Yeah, so they get really, really, really tired when they have a high fidelity suit. Yeah. What I was missing recently, and I don't know, training. Yeah, I have asked some analog astronauts. So when you go out in these spacesuits, do you actually train how to fall and how to get up after you fell? And they were surprised about that question. Should that be included in the training? That how, if I stumble, how do I fall without causing too much damage to A, myself, and B, the spacesuit? And once I'm on the floor, how do I get up? Because if you have a high fidelity spacesuit with that weighs 50 kilo with exoskeleton and everything, that's not the easiest thing to do. Would you include such training? Or do you say, no, this is too dangerous because they can actually get injured?
It's not inevitable. They can fall, right?
Yeah, of course.
So they should know the procedure.
Yeah.
I say we do it, maybe with some, some cords and everything first off,
Yeah.
so they don't actually fall. They're like tied to something.
Yeah. Mano says, I think we should, much like special forces do. Yeah, I did horse riding, and I still do it when I have some time. But we did not only learn how to ride a horse, we also learned how to fall off a horse properly, how to roll over and these things, so we don't get injured in case we fall off the horse. Yeah. And yeah, how to fall in space without injuring yourself or and how to get up again. Yeah.
I have to ask this.
Yes.
Do actual astronauts carry duct tape with them? I see.
Do actual people carry duct tape with them? Of course. Look into my handbag.
So like, I'm a big fan of Martian, and I've seen like Matt Damon had the
Yeah.
duct tape. So I don't know like how real is it? Like, do spacewalkers carry that?
Not, yeah, I don't know if they carry it on every space suit. On every spacewalk. Sorry, I'm getting tired. But yeah, for certain things they repair things with duct tape.
I see.
Yeah.
And is it
a classical example? I think it was it the first time when they used this car on the moon, and the fender came off, and it was just distributing regolith all over, and they actually fixed it with duct tape on the moon.
I see.
So yes, so shall we say suit technology, suit systems, a holder for duct tape?
Yeah. And I don't know like what else do astronauts actually carry with them, when they go for troubleshoot or spacewalk. Like, what are those necessary things that you actually have to have with you just in case some emergency arise? It doesn't have to be a lot, but what can fix most of the problem kind of
yeah
thing,
Duct tape. Yeah, they usually, even the analog space suits, they have either, if you get them from the DIY store, they have lots of pockets where you can put a screwdriver and a wrench and the duct tape. But also the high fidelity space suits, they have kind of a small chest that you can open, like a toolbox, mini toolbox, yeah, where you have your tools in, and also sometimes you need things for experiments, yeah. You need some drill to take soil samples or something like that. It doesn't even have to be repairing, but if you have an analog mission and you're required to do certain experiments, some experiments come with tools.
And I think I can relate it to where on the suit you need to have these, because then it comes to the question, should you train for a fall? What if you fall on those things, you know, how do you fall? And it all depends, like it all comes into question and picture.
Yeah.
Yep.
And you should, of course, if you train how to fall, you should train how not to fall
on certain things, on certain sides or angles.
Yeah. Yeah. Location of tools is important. Yeah. For accessibility, of course. And avoiding injury in case of can't type anymore. Yeah. Tools or toolbox. Yeah, you need to, of course, have it close by so you can actually reach into it. It should not be at your ankle, so you have to bend down to get to pick up your screwdriver. So yeah, it should be, because that comes with its own danger. Yeah. Okay. Anything else? That we can think of? Shall we put the remark that the helmet is really a key part of the suit system, because there's so many things going on in the helmet? What do you think? Does the helmet require special attention? Anyone? Or is it just another part of the suit? Hello.
Karen, are you ready for the exchange?
Yeah.
Perfect. Okay. So I think Sam will now send them to do it. They got scared, but it's going to be useful for the recording.
Yeah. I'll talk to you guys. So we weren't really following the board, even though I made it. So we were just sort of going through different points we thought were important about suits, trying to work out stuff about them. So the first thing we sort of talked about is, are spacesuits actually necessary for analogs in the sort of normal sense of it? And we said that yes, probably. You don't need to have a very good suit necessarily, but having a suit is important for having just the baseline level of fidelity. But it's not worth it. What we kind of agreed upon is that you need to have a suit, which is maybe like £1,000 suit, minimum baseline. But then you shouldn't start making it more fancy until you have other things in the mission vehicle. So fidelity, so it's not worth having a really good suit with a really bad planning system, because then the student ends up being like a sort of So that was kind of thing we said about that, about the cost and the necessariness. We kind of agree the most important sort of thing to consider in the design of it overall was anti-fogging on the visor, because that's really hard to get right, especially if you're in, like a lot of missions here, with high humidity, cold environments, which means you end up with a lot of water in the air and in the helmet, and then it all condenses out. And we had a long talk about different ways to deal with that, sort of airflow things and having active dryers in the suit. We didn't really agree on the best option. There's a few things we think. We had a bit of talk about modularity and size. Sort of said that it should definitely be modular in some way, so you can have sort of take the arm off and sort of have bits you can change out. There are probably parts that should be at least sort of custom fit to the user. So think about the length of the arm needs to be right, where it's quite hard to sort of do what EVA to be comfortable with them. Other stuff, active like thermal management is also sort of quite a big problem for almost everyone who's been in a suit or been on a mission, where you almost always overheat the suit. So having sort of a way to actually cool off is important, and managing sweat is very important. So having the Lunara suit has a plastic sort of waterproof layer you wear over your sort of underlayer, but you wear it between yourself and the outer suit, so that can be thrown away at the end of the mission, at the end of the EVA, and it still doesn't make everything else smell. Well, suit sensors. We have to talk about suit sensors, about what's important to have in the suit. We all agree the CO2 in the air is most important to have, because that's sort of the real mission aboard number. But then, as far as other sensors, humidity and temperature in the suit air is useful, but you can't do very much about it. So it may not be the best to have if you only got sort of a limited budget of sensors. It might be better to have things like sort of a biomedical sensor, heart rate, blood oxygen levels, like that. Although we did also discuss you could do that with like an Apple Watch often has, or like some off the shelf like sports watches have quite a lot of biomedical sensors that you could use. If you can integrate that in real time with a cable or with Wi-Fi, that can be quite a cheap solution for that. We also did a few things about making instrumented gloves. So as a way to get around the fact that you really want to be quite inflexible with your hands to get the high fidelity. You should be able to do small motions in a spacesuit, in an analog spacesuit glove. One option would be having lots of equipment already on your arm and your hand. So having sort of sensors you can put into the ground or cameras you can have on the wrist and point things without having to handle lots of tools would be a really good way to sort of make the astronauts' lives easier and increase fidelity by not having them handling small tools. That's kind of all we're talking about. That's kind of a summary, but there are lots of different small pieces. In terms of food and water, like having food in the suit, it's probably good to have a sort of pouch of water you can have with a straw, and you could maybe even have like sugar in there, or electrolytes, or like something like not like food, you can get some calories out of as an alternative. Or you can have chocolate in the suits, which is melted by your body heat, and then you have chocolate, which is the Swiss option for the suit. But yeah, we just had there's lots of other sort of we were just sort of talking about lots of different parts of it and bouncing around different topics. So that's kind of the summary.
Well done. So your turn to shine. Who's presenting, Karen?
Yeah, it will be Bhumika and myself. So yeah, we had some thoughts about analog spacesuits in general, because what we see is a full range from an overall bought for $19 in the local DIY store up to real spacesuit simulators with extremely high fidelity. And every one of these, and anything in between, of course, and every one of these has their own merit. Not for every experiment we need the highest fidelity type of suit. It really depends on the goal of the missions. But our thoughts were that we, for example, we can sort of standardize spacesuit classes. Yeah, we have a class A, class B, class C, class D. So we can make missions more comparable and maybe bring the cost down if we bundle across missions the purchase of such spacesuits. And we also said we need to consider that there will be some underwater analog missions that we also need diving suits in terms of spacesuits. So these were just like general thoughts. And then we have talked a lot in depth about suit systems. Maybe Bhumika, you would like to say a couple of words about that?
Yeah, thank you, Karin. Hi, everybody. Yeah, so we talked about like what should be the human factors in terms of like, you know, visibility, flexibility, like the movements of the spacesuit, how the fit comes into play, you know, the sizing and fit. And that's where inclusion, I think, is very important about time, you know, every kind of person, and thermals, like how temperature regulation is a big thing. You know, some of the missions are going to be in the, I don't know, high altitude deserts where it's cold and dry. Some of them are going to be in place like Brazil in Habitat Marte, where it's like really, really hot at this time of the year. Some are, you know, going to be in the polar regions where it's like really, really cold. So how do we take care of the thermal regulation in suits without, you know, increasing a lot of cost for these analog spacesuits? And then do our suits need to be intelligent? And if so, like what kind of technology do we need? Like what kind of information do we need on our visors for the person who is in the suit to be able to read, analyze, and properly communicate with the mission control? And do we need like vitals for the suit to be recording all the time? And then the next thing is you're collecting all this information. As Karin said, data security is very, very important. Like, how do we secure the data? We can sign all these NDA deals, you know, but at the end, it kind of comes to the personal decision, like if we want to have that data on the web everywhere, and how do we protect it? And then the next is like fidelity. As Karin said, we need to have classes of spacesuits, because you can't just pick a high fidelity spacesuit, invest a lot of money in that, and just pick up soil samples with that. You know, it doesn't serve the purpose. So I think having class of spacesuits is very, very important to control the cost, to serve the purpose, and have the practicality of that spacesuit, like fully optimized suits. Like, how do we fully optimize the design and everything? And how do we fully utilize that design to serve the missions, right? And at the end, I think I'm a big proposer of we need a policy-making body for our analog missions. We do not have that, I think, and that divides the question, like who are the people who need to be included in this, you know, policy-making body? I think it's like experienced people who have actually served the missions, people who are inventors, people who are thinking about this technology, you know, going into space and everything. I think inclusion is very important. If we're trying to include men, women, people with disability, you know, everybody, I think inclusion is a big part of having a successful analog spacesuit, right? So yeah, this is my summary for the spacesuits. So Karin, back to you. I don't know if you have any more thing to add.
Yeah. If we can just, thank you very much, Bhumika. From the human factor side, of course, the spacesuit has to have a reasonable degree of comfort, so that the astronauts feel comfortable doing their work, and then being even in an analog mission 6-8 hours in the suit, and carrying out their work. It has to be done in a way that it's comfortably fitting, and that is also the donning and doffing doesn't take too much time. We need safety procedures, for example, for emergency doffing. We need to make sure that the atmosphere inside the suit is very agreeable, and not only in terms of temperature, but also in terms of humidity, in terms of airflow. Yeah, we don't want to have like gale force 11 inside the suit to keep us cool. So we have to consider these things also when it comes. We have talked about a lot of intelligent suits and assisted systems, artificial intelligence. But if we look at the human side of it, the analog astronauts usually don't want to be dominated by technology. Yeah, technology should help them, and the suit should help them, but it should not be kind of overbearing and the suit giving all kinds of alarms at all kinds of times. So we have to find a good balance for that. And Bhumika already mentioned it. It has to be a good fit. And we were talking about this example for a couple of years ago. The first planned all-female spacewalk did not happen because the right suit size was not available for one of the ladies. And these we have to make sure in our analog mission that this doesn't happen. Yeah, that we take care of also different body shapes of men and women, and of tall people and small people, and be more inclusive also in the design of the spacesuits.
You know what I think about it, like inclusion, Karin, just for a minute. You know, we have like all these, it might sound a little awkward to some people, but I'm going to say this, like we have all these lingerie making, like, you know, companies that are like working towards like, you know, all kinds of like size, like curvy, straight, skinny, petite, tall, right? Why not we just, you know, do like collaborate with them? I'm sure they're going to come up with some really inclusive design for women, and I think that spacewalk can happen anytime now if we, yeah, and men, you know, yeah, like, I mean, we're only limited by our imagination and who we want to collaborate with, right? So you never know. And
the last point that we haven't really mentioned yet is we talked a lot about training. Yeah, how that we of course need to train, especially when we're talking about high fidelity suits. It requires training how to put them on, how to take them off, and not only for the analog astronaut, but also for people assisting with donning and doffing. And we would also very much like to include some training of how to fall properly in the spacesuit. Now, if you stumble over a rock, how do you roll over in order not to injure yourself and not to damage any equipment? And once you've fallen down, how to get up again? Because if especially high fidelity spacesuits are very expensive, very heavy. See, you have an exoskeleton limiting all kinds of movement. So what happens if an astronaut stumbles and falls? We would also want to include that in the training, which we don't see at the moment included.
And to a little bit add on to that, like suppose somebody falls and I don't know, damages, and that comes to the point of like damages the suit and the network and power for the suit. How do we distribute the power for the suit in case of emergency? Like what systems need to be on all the time because they're very, very important, and what can be turned off because, you know, at that time they're just not useful and they're drawing a lot of power. And I'm not sure like what power source do we use for analog spacesuits? Like, is it just going to be batteries, lithium-ion batteries, or something else? If we want to go into nuclear or thermonuclear. But then, of course, it comes to the fidelity of the spacesuit, like how risky we want the spacesuit to be. So those kind of questions come into mind.
Yep, that's it from our team.
Great. Well done. So anyone has any questions, anything they'd like to mention perhaps? So yeah, I actually wonder if there's going to be a standard of spacesuits in the long run. I think when you see different analog space missions, where you see the biggest difference is in the spacesuits. So I think it's actually a biased thing. It's just because the spacesuit is what's in the media. The spacesuit is the way that you show the analog mission. You know, it's like it's the astronauts. The astronauts are the image of the mission, and it kind of biases the view of everything. But at the same time, I think it's important that we can work on them and also feel a sense of appropriation. So I think the one thing that we mentioned is good to have spacesuits that are either modular or made for each person. And if we're going to have power astronauts, it's going to be more and more important. But what you mentioned about different classes of spacesuits is actually very interesting. And if we could have somebody manufacturing them, and we could have them all within a budget that would make it accessible for different missions. So maybe an analog mission will say, well, we are ready to put 15,000 bucks in it, another one's 10,000, another one's 5,000, another one's 2,000. So you got 4 classes of spacesuits, but it would still be good enough that it wouldn't damage the mission's reputation or use, for example. That'd be interesting.
And we said we don't want one standard spacesuit, analog spacesuit, because that would totally limit the options. Because as the Bhumika said before, if we just need to pick up and analyze soil samples, what do we need a high fidelity 50 kilo spacesuit for? If we, for example, if we just want to check if a procedure works, maybe the overall from the local DIY store is good enough for that. So there is room for everything. This is why we came up with the idea of rather than having one standard, but having classes. And there is a couple of letters in the alphabet, depending on which alphabet you take.
Let's go with 26 options. I think that's enough already.
There is many more in the Slovak alphabet.
I know, we don't need the Slovak alphabet. It's too big.
So this is why we thought maybe a couple of classes would do.
Actually, also one thing, so we mentioned before the watches that, like, you know, smart watches. Alejandro, can you come here? Can you show me the watch on your wrist? Is that the Korea astronaut one? So Alejandro and I are part of the Korea astronauts candidates program, and this is supposed to be our astronaut watch, and it looks a bit like an Apple Watch, and it's got a sensor, and they're developing something called BioStrap, and they make us do exercises and monitor our health data. And for the moment, we don't know how safe the data is. So normally it should be, like, they're not trying to screw us over. But it's quite interesting to see that they send this and they're going to test it in parabolic flights. And so potentially these watches might then be used in analog missions. I think the triathlon watches that we use, like Garmin watches, usually are quite good enough, good sensors. But it's interesting to see that there's already a movement in that direction that might become maybe standard for spacesuits for analog missions.
Yeah, or like Fortis watches, they've actually made a movie of the Amadi 20 mission. The watches there,
So actually, that's one point that we really agree with you, with these different levels of technology, but also depending on the customers, you know, of luxury. But what we could address as a federation of analog research groups is really to make an inventory of some of the model, but also accessories, and then we could even serve as a service, like
You just gave me an idea for the wiki page for CHASM. We're going to put this. We're going to do an inventory of the spacesuit.
Yeah.
We have so much work to do.
And we saw also you worked a bit on cost and on angel investors, and we thought, you know, the same way you have, you know, some sport shop, and we were talking about Swiss ski shop. Should we have the ambition to start a line of product of astronaut, analog astronaut fashion and accessories?
Yeah,
So who is
Bernard,
You'll be on the catwalk, you know.
I know better candidates, but I think and in particular, if you have something that would lead to a business like a startup that will do this task for us, we have some funding for you. With our Eurospace group. So collecting the information, also a catalyzer for development, defining market and so on.
Yeah.
So let's work on this. We start with the wiki.
Bernard, I think you have quite some good connections. And also Hossam said that he can build a spacesuit for $1,000 high fidelity.
Yes, so we were looking also at a range of prices. Yes, so our analysis is like the €1,000, we're talking euro here, €1,000 product is something that could be both useful, but also could be built in a large
technical and fashionable, a little bit. Won't be great, but it would work. It would work. Yeah. So cool. So we got anyone wants to do a spaceship startup for analog? 1%. We're fishing.
But we are also connecting to those that are, you know, being built, and so we can start with that. But after, also look at the distribution of analog solutions. Then we have to go to the big fashion and sport, lifestyle.
Cool. Any other things that spacesuits?
Any contribution?
Anything you'd like to say on spacesuits before we wrap up the work?
Yeah, next time we organize a fashion show.
Next time I think Sean knows the spacesuit is coming out.
Yeah, and for this, it happens. We haven't funding to
So yeah, I think we completed most. Did you manage to record? Yes, you managed to record. That's good.
Okay.
Don't know if any of you